Creating box plots. The box plot, or sometimes called a box and whisker plot, is a graphical summary using the 5-number summary and the interquartile range, or IQR, of the dataset. Box plots are used to evaluate the skewness, left or right, or the symmetry of the data, and then its spread. So let's go through and see our steps in drawing a box plot. Now we have about 6 steps. Step 1, find the 5-number summary. Now we've already done that in our previous examples because down here where I've starred, I'm using the same data set to do our example here. So we've already found our 5-number summary. So step 2, and we'll put the values down in a minute. Step 2 is find the lower and upper fences by using the IQR, or the interquartile range. Now, we haven't done this yet. That's what we're going to do next. But we have, for the fences, we're going to use this notation of a bracket. That's for the lower fence, and the other bracket to designate the upper fence. Okay, what fences are is it kind of organizes the data so if anything is to the left or right of those fences, then they're considered to be outliers. So our lower fence is equal to quartile 1, which is our lowest quartile, minus 1.5 times the interquartile range. Now, we know from our previous examples that position 4 houses our quartile 1, position 8, quartile 2, or the median, position 12, quartile 3. And again, this data table is smallest to largest and numbered. Okay, so we're going to take quartile 1. That is 69 minus 1.5 times the interquartile range. Well, let's do a review. Interquartile range is given as quartile 3 minus quartile 1. Well, that is quartile 3 is 85 minus 69. That gives us 16. So our interquartile range is 16, so 1.5 times 16, and we get 69 minus 24. Okay, our lower fence then is a value of 49. Or 45, excuse me. Get eraser. Okay, now upper fence. This is the other end of the data. Quartile 3, well, quartile 3 is 85 plus, because we want to go past that quartile, 1.5 times 16, so 85 plus 24. Our other end, if we add those, we get 109. So those are our fences. Okay, so 5-number summary. We know what quartile 1 is. We know what quartile 2, quartile 3. We know that our first data piece is our minimum, and our 95, or our 15th piece, is our maximum. So we have our 5-number summary now. And we found our fences. Okay, now, next step. Draw a horizontal line and mark the fences, the median, the quartiles, min, and max with vertical lines. So let's come down here, and what we've done is I've created a number line, evenly spaced, and we're going to put our fences on and our 5-number summaries. Our fence, our lower fence, if we remember, was 45, our minimum 56, quartile 1 69, median 77, quartile 3 85, max 95, and our upper fence again was 109. Now 109 is past the number I have on my number line, so I'm going to go ahead and make another line and put 110 evenly spaced so I can figure out where that is. Okay, lower fence at 45. We come up on our number line, 40 and 50, between that is 45, so I'm going to put our bracket that marks our fence at 45. Okay, our vertical line for a minimum is a 56. Again, I come between 50 and 60, and somewhere there, about halfway, draw a vertical line. Quartile 1, we have to mark that at 69, and that's going to be really close to 70, and again, best you can do, another vertical line. Median, 77, again, somewhere close, a little bit above half. Quartile 3, 85, right in the center, between 80 and 90. Our maximum is 95. And then our upper fence, 109, which is really close to 110, but again, it's going to be a bracket. Okay. So again, our lower fence, that's at 45. We want to label it, we can. Minimum, 56. Quartile 1, 69. Median, 77. Quartile 3, 85. Maximum, 95. Upper fence, 109. Okay, so now that satisfied step 3. Step 4, connect the first and third quartiles, top and bottom, with horizontal lines to form a box. Okay, so let's come down. So, quartile 1 was 69, so we're going to take quartile 1, starting at the top, and go to quartile 3, which is 85, and we're going to connect the tops. And we're going to connect the bottoms. Now what's happened is the median now is inside the box. Okay, so we've done that, step 4. Step 5, draw a line, and what they mean is a horizontal line, or a whisker, can be called, from the first quartile to the smallest value before the fence. Okay, so here's the first quartile, the end of the box, and here's the smallest value. Remember, 45 is not a value, that's a fence. So 69 to 56, that's our first whisker. And now we do it again from the third quartile to the largest value before the fence, which is our 95. So third quartile to the 95, there's our other whisker. Okay, basically we're almost finished our box plot. So that's step 5. Now, note, if the min or max are outside of the fences, in our case they're not, our min and max are inside of our fences, but if they're outside, then they are outliers. Any value beyond each of the fences in the data set now is marked with an asterisk. These are the outliers. So for example, suppose our data set had a value of 110. Well, our fence is 109, so 110, our data value would be way out here. That would be marked as an asterisk, or would be an outlier. Okay, so there's our box plot. So we're finished our box plot. Now let's analyze it a little bit. The inside of the box is going to tell us the skewness, okay, or the symmetry. If the median line in the center is in the center of the box, then the data is symmetric. However, if that box, and right below here I'm going to draw another box, if, for example, the line or the median was this end, then our data would be skewed left. Okay? Inside the box, the little box here is where all the data would be bunched up, and then the bigger part is where the data would be more spread out, so that would be a skewed left. Well then, of course, if that's skewed left, then if we had the opposite occur, where the line was more towards the left, then this would be a skewed right graph. Okay? So, symmetric, median's in the middle, median pushed to the right, skewed left, median pushed to the left, skewed right. Okay, now as far as the spread goes, the whiskers are telling us how this is spread. So, because the whiskers do not seem very long and they don't go out past the fences, then we could say that this has probably an average standard deviation. It's not going to be anything big, it's not going to be anything little. However, again, let's look at another drawing. If I had a box that was small, symmetric, but very long whiskers, then this would tell me that my data would be very spread out, versus a box, again, can be symmetric and have very short whiskers, then my data would be it would not be spread out. Our standard deviation would be smaller. So longer whiskers, higher standard deviation, smaller whiskers, smaller standard deviation. That's the end of our example.